We're going to be looking at fractions, and if we turn to page 43 in our workbook, then we can follow along as we go through fractions. Now, first thing we need to know what a fraction is, and the book says a fraction is a number that can be used to describe a part of a set or a part of a whole. Every fraction has two parts. The number above the bar line is called the numerator, and the number below the bar line is called the denominator. So the numerator tells us how many parts are named in the fraction, and the denominator tells the number of parts into which the whole is divided. And they have a circle there, and one part is shaded red, and they have labeled it a quarter, and the top number they label the numerator, the bottom number and the number at the bottom is called the denominator, with the line in the middle being called the bar line. In some places it's called the fraction bar. Okay, so in this case we have one part being shown, so it's one part out of 4, and that would be representing the shaded portion. Okay, while the unshaded would be 3 parts out of 4. So we would have had one part there, 2 parts, 3 parts out of 4 be unshaded, and 1 part being shaded. If we were to add these together, we would end up with adding our numerators 4 over, and there's a rule that says if the denominators are the same whenever we are adding, we should keep them. So it would be 4 over 4. Another way of reading this is, how many times could 4 go into 4? 1 time. So what this is saying is, if I have all the parts of this circle, then I would have one whole. Still on page 43, let's look at exercise 1. It says study the diagrams below, and let's look at figure A, which I have on the screen here. And if we were to look at what fraction of this is shaded, it would be 2 parts out of 3. What fraction of B is shaded? This would be 1 part out of 2, and this is divided into 1, 2, 3, 4, 1, 2, 3, 3 times 4, 12 pieces, and I have 1, 2, 3, 4, 5, 6 pieces shaded. Okay, so this would be 6 out of 12. So this represents the shaded section. So this is the shaded, and the unshaded portion would now be 1 part out of 3, representing there, and this would be 1 part out of 2, and this would be 6 parts out of 12. So for the shaded we have 2/3, the unshaded a third, shaded a half, unshaded a half, shaded 6/12, unshaded 6/12. Let's look at exercise 3, number 1 to 3 on page 44. It says how many fifths must be added to 1/5 to make a whole. So we have 1/5, and we need to make a whole. We're going to add some to it, and then we need to end up with 5 over 5, because 5 over 5 is the same as a whole. So we could simply look at these and say I would need to add 4 more pieces out of 5 in order to get the whole. Okay, 4 more pieces out of 5 in order to get the whole. So I would add, my answer would be 4/5. I would need to add 4/5 in order to get the whole. Okay, and we can show that one, 2, 3, 4. So I have 1, 2, 3, 4, 5 parts, and I have 1 part. That's where our problem started. How many more pieces would I need to put with it? Each of these sections would be called 1/5. Okay, my diagram is not very neat, they're not very equal, but the idea is that each of these is 1/5. So now I would need to add how many more? 1 more, 2 more, 3, and 4. So adding 4/5 to that plus 4/5, and I would get 5/5, which would be the whole. Again, my answer is 4/5. So this would have been number 1. Let's move on now to number 2. It says, what must be added to 6/10 to make a whole? So we have 6/10, and I need to add to it to get it to be 10/10. So 6 and what would make 10? 6 and 4/10 would make 10/10, which is equal to 1 whole. So again, my answer in this case is 4/10. Okay, so answer equal 4/10. Number 3 said, what must be added 4/9 to make a whole? So we have number 3, 4/9 to make a whole. What would we need to add? We would have to add 5/9 to get 9/9. We had 4 there already. 4 and 5 would make 9. Remember, if the denominators are the same, we keep the denominator the same and focus on the numerators. So we're on page 45 now. We're looking at equivalent fractions. Equivalent fractions, as defined by the book, have the same value and therefore name the same amount. Okay, in class we came up with our definition that says equivalent fractions, they have different names but they have the same value. Here we have a rectangle, not a very pretty one, but it's divided into 2 pieces. One is shaded, and that would be a half. I'm going to add another line to this. Now, what's a fraction? We have 2 pieces. 2 pieces out of 4. Has the amount of the shaded portion changed? No, it has not changed. So it has a different name, but the amount is still the same. The value is still the same. So we could therefore say that a half is equivalent to 2/4. Okay, alright, let's go again. I'm gonna add a line here and a line here. Okay, this last line would be centered better. Now, same amount here, same value here, but now this would be 1, 2, 3, 4 shaded pieces out of a total of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, this is saying that a half is equivalent to 2/4, and a half is also equivalent to 4/8. Okay, one more. We cut like this, and we cut like this. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces now. 8 pieces that are shaded out of 16. Now we'll stop here. So far we have 1, 2, 3 equivalent fractions for a half, being 2/4, 4/8, and 8/16. So we can clearly see that each time we added lines, a line or lines, the value, the amount of the shaded portion did not change, but the name changed. So when we added one line, we had 2/4, and the more lines we added, the more the name changed, but the value, the amount of the shaded part, did not change. Basically, that's what equivalent fractions are. Now, to find equivalent fractions, what we do, we can multiply the numerator and the denominator by the same number, okay, or the same factor. So in this case, we could try 2/2, and 2 times 1 will give us 2, and 2 times 2 will give us 4. So using the factor 2, we can multiply the numerator and the denominator to come up with an equivalent fraction 2/4. Again, we could multiply by 4, coming up with now an equivalent fraction of 4/8. 4 ones being 4 and 2 4s being 8. A half, we could multiply by 3, coming up with an equivalent fraction of 3 ones, 3 over 3 2s, 6. Again, a half multiplied by 4. 4 ones, 4, 4 2s, 8. We had this one already. Let's try 5. 5 ones, 5, 5 2s, 10. 6. 6 ones, 6 numerator, 6 2s, 12 denominator. So all of these are equivalent. Okay, let us move on now and look at exercise 1, and they have done example 1 for us already, so we'll only look at example number 2. So exercise 2, no, exercise 1, we're looking at number 2 on page 45. So they have given us 2/5, and we're supposed to make equivalent fractions. They have 4/10, 4/10, then 6/15, and we're supposed to supply the rest. Now, what did they do to 2 to get it to be 4? They multiplied by 2. So the factor they multiplied the numerator and the denominator by was 2. What did they do to 2 for it to become 6? They multiplied by 3. So 3 2s would have given them 6, and 3 5s 15. So they have done 1, they have done 2 and 3. Let's go with 4. 4 times 2 would give us 8, and 4 5s would give us 20. Then let's go to 5. 5 2s, 5 times the 2, numerator 10, and 5 times 5, denominator 25. 6 times 2 would give us 12, and 6 times 5 would give us 30. Okay, last one, let's look at So using 7 now, 7 times 2, 14, and 7 5s will give us 35. So I hope we get that one. We just multiply the numerator and the denominator by the same number. So now we move on to exercise 2, page 45, and we're going to be looking at number 1, 2, and 3. Following the same principle of establishing what factor we can use to make equivalent fractions. So here they have in number 1, they did number 1 for us already. They have 6 sevenths is equal to 12 fourteenths. What did they do to 6? They multiplied by 2, and whatever we multiply the numerator by, we need to multiply the denominator by that also. So 6 2's would have given us 12, and 7 2's would have given us 14. So 6 sevenths and 12 fourteenths are equivalent. Now they ask us in this case to find the numerator. So they have 3 17ths is equal to something over 51. What did they do to 17 to get it to 51? What factor did they multiply by? 17 by 17. 17 times 2 would give you 34. So 17 and 17 would give you 34. And if we add 17 more to that, we have 7 and 4 11, and we have 51, which is the same as saying 17 times 3. Okay, so 17 times 3 would give you 51. So they multiplied here by 3, so therefore we would need to multiply the numerator by 3. So 3 times 7 would give us 21. So we'll end up with 21 over 51. Number 3 now, we have 5 nines is equal to something over 15 over something. And in number 2, we didn't know what the numerator was. In this one, we don't know what the denominator is. So what did they do to 5 in order for it to become 15? They multiplied by 3, because 3 5s will give us 15. So if we multiply the numerator by 3, we need to multiply the denominator by 3, and 9 3s would make 27. So our answer in this case would be 15 over 27. We turn to page 46, and we're looking at reducing fractions. It says, to reduce a fraction, divide the numerator and the denominator by the same number. Repeated division can be used until the numerator and the denominator have been reduced to their lowest terms. They have an example here. They have 12 18ths. Okay. And they say, if we divide the 12 by 6 and we divide the 18 by the same 6, we would get 6 into 12 2 times and 6 into 18 3 times. Okay, that's one approach. They did cancelling also, and they said 12 over 18, same 6 into 12 2, and 6 into 18 3 equal to 2/3. Okay, now in order to reduce quickly, we can find the highest common factor, or what we call the HCF. What is the highest common factor of 12 and 18? Let's go. We put our numbers down, 12 and 18. and we would try to see what number can go into both. Okay, 2 can go into both of these. 2 could go in 6 times, and 2 could go into this 9 times. 3 could go into this, yes. 3 could go into 6 2 times, and 3 could go into 9 3 times. Now we cannot find a number that can go into both of these without leaving remainder. So we multiply whatever we have outside, and that would be our highest common factor. Okay, so 2 times 3 would give us 6. So in this case, the highest common factor was used to divide 12 and 18, and we got 2/3. And if you look here, we had 2/3. It couldn't go any further than that. Okay, so when we're reducing, it's best to use the highest common factor. We can use other common factors, however it will take us a little bit longer to get all the way down. Let's move on. So now to exercise 1 on page 46. We have 4/8, we have 15 over 45 and 8 over 32, and we must reduce those. So the highest common factor of 4 and 8 would be 4, and we could say 4 into 4 would go 1 time, and 4 into 8 would go 2 times. So our answer is a half. The highest common factor of 15 and 45 would be 15. So 15 could go into 15 1 time. 15 into 45 could go 3 times. Our answer would be a third. And the highest common factor of 8 and 32 would be 8. 8 into 8 1 time. 8 into 32 goes 4 times. Our answer is a quarter. Let's use our little ladder and find these highest common factors first with 4 and 8. Using 2 could go into 2 times, and 2 could go into 8 4 times. Using 2 again, 2 could go into 2 1 time, 2 could go into 4 2 times. Can I find any number that can go into both of these? No. So we multiply everything outside, and we say our highest common factor would be 4. So that's what we use here. So we divided the numerator by 4 and divided the denominator by 4. When we were finished, we ended up with a half. Okay, so 4 over 8 divided by 4 divided by 4 is equal to a half. So it's the same thing as is here for number 1. For number 2, let's make a little space. For number 2, we have 15 and 45. We could use 3. 3 into 15 will go 5 times, and 3 into 45 will go 15 times. Now we could use 5. 5 into 5 1 time, and 5 into 15 goes 3 times. We can't find any number that would go equally into both 1 and 3. We multiply everything we have outside. So the highest common factor here is going to be 15. That's why we said 15 divided by 15 is 1, and 45 divided by 15 will give us 3. Same principle for number 4. We have 8 and 32, and in this case we could use 2. Always start with 2, and we say 2 into 8 4, and 2 into 32 16. Then we could continue with 2 if we wanted. 2 into 4, 2 times 2 into 16, 8 times. We continue with 2, 1, and 2 into 2 1 times, and 2 into 8 4 times, and we're done. So this would be 2 times 2 times 2, or 2 cubed, which is equal to 8. 2 2s 4, 4 2s 8. So highest common factor here being 8, so our HCF is equal to 8. So we use 8 to divide the numerator. 8 into 8 goes 1 time, and 8 into 32 would go 4 times. So basically that's what reducing fractions is all about, trying to find a factor, common factor, that will go both into the numerator and to the denominator. Reducing using the highest common factor is the fastest way to reduce. If you use other common factors which are not the highest, you will just take a little longer time in getting to the answer. So we turn to page 47 now, and we look at comparing and ordering fractions. We say which is larger. They have 3/4 and 9/16, and they have some steps when we are going to be comparing the fractions. If the denominators are different, then we need to write them with a common denominator, and then we compare the fractions. Okay, to find this common denominator for 4 and 16, we need to do something to 4 to make it into 16, and we could multiply the 4 by 4 to make it into 16, and whatever we multiply the denominator by, we would also need to multiply the numerator by that same number. So solving the same problem or item that they have presented, they gave us 3/4, and we were to compare it with 9/16. Okay, so we are to compare, and in comparing we could say that something is less than, equal to, or greater than. So let's look now. We need to make this equivalent. That's what we do when we find common denominators. We make them equivalent. So if we multiply this by 4 and multiply this by 4, we now end up with what? 12 over 16 and 9 over 16. Okay, so we now write our statement. We could put one of these symbols in. We could say 12 over 16 is greater than 9 over 16. Okay, so 3/4 is larger. So 3/4 is larger than 9/16. They go on to say that if the numerators of the fraction are the same, the fraction with the larger denominator is smaller, and we can use the fraction board to compare. So that's another approach that you can take. Let's move on to exercise 1 on page 47, and let's look at items 1, 2, and 3. So it says circle the fraction which is larger. So we're going to look at number 1, which is 3/8 or 5/16. So we would need to multiply by 2 in order to get this to be 16 too, and we'd multiply the numerator by 2 also. So this would now be what? 3 times 2, 6 over 16, or 5 over 16, which is larger. 6 over 16 is larger. Okay, so we move to number 2. Number 2, we have 1/8 or 3/16. We're dealing with 16 again, so we would multiply by 2. Okay, so 2 ones would give us 2 over a 2/16 or 3 over 16, and 3 over 16 is larger. Number 3 says a half or a quarter, and we could multiply by 2 because 2 2s will give us 4 and 2 1s will give us 2. Okay, so in each case the denominators have to be the same thing for us to compare them. If they are not the same, we cannot compare them. Our first step is to make them common. Okay, so we definitely know that 2/4 would be larger than 1/4. So again, just to go over this, we have to make them equivalent. We have to make the denominators common, and we do that by seeing how best we can use a factor to multiply the numerator and the denominator so that both denominators will have the same number. In this case, we have 8 times 2 would give us 16, and since we multiply the denominator by 2, we have to multiply the numerator by 2, thus making the entire fraction equivalent. Okay, so after we make them equivalent, then we can compare using the numerators to see which one is larger or smaller. Okay, we're on page 48 now, and we're going to be ordering some fractions. Okay, so it says we need to rearrange these fractions in order of size from greatest to least. That's descending order. So descending from big to little. So we need to make all of these have the same denominator. Now we would need to find something that is common to all of them, a denominator which would be common to all of these. So what could we do anything to 2 to make it become 8? No. Could we do anything to 6 to make it become 8? No. We could do something to all of them to allow them to become something else though. We could make all of them become 24. We could multiply 2 times 12, and this would become and multiply the numerator by 12 also. This would be 12 over 24, and we could multiply 1/6 by 4, multiply the numerator by 4, and we would get 4 over 24, and we could multiply 8 by 3 and 5 by 3 to get 15 over 24. And we could go on and order them now, and we could say that 5/8 is the largest one. So 5/8 is largest because the equivalent fraction for 5/8 is 15 over 24, and that's the largest one here because the numerator would tell us which one is largest. And then we go to 12 over 24, which is the same as a half, and finally 1/6. Okay, so 5/8, a half, and 1/6. There is an easier way to find what the common denominator could be. We could use the LCM approach to find it, and we write 2, 6, and 8, and using the lowest prime factor. 2 into 2 1 time, 2 into 6 would go 3 times, and 2 into 8 would go 4 times. We continue with 2 because 2 could go into 4. 2 can't go into 1 without leaving a remainder or anything like that, so we write it back. Same thing applies for 3, but 2 could go into 4 2 times. You continue with 2, and it could go in there 1 time. Now we go 3. 1, 3 into 3, 1, 1. We draw our L on the outside to show we're finding the LCM, and we multiply everything on the outside. Of course, 1 times 1 times 1 is 1, and 1 times whatever we have out there will give us whatever we multiply and get. So this is 2 times 2 times 2, which is 2 to the third times 3. So 2 times 2 times 2 is 8 times 3, which would be equal to 24. So if you had any difficulty looking at 2, 6, and 8 and trying to say what could I find as the lowest common denominator, then using this approach you could find very quickly that 24 is what you should use. Okay, in that case, you know, it could look something like 1/2 over 1/6 over 1/8, LCM being 24, and 2 into 24 would go 12 times, so 12 times 1 would make 12, which is what we got here. Okay, and we could say 6 into 24 goes 4 times. We say 4 times 1 would make 4 over 24, which is what we got here. And 8 into 24 could go 3 times. 3 ones 3. No, I have something wrong here. Hold. This is not 1/8, it's actually 5/8. So 3 5s will give us 15. Right. So it would have been 15, which would be the same here. So 12 over 24, that's how they have it as one fraction. And then 15 over 24 and 8 over 24 and 4 over 24. So whichever approach you find easier, if you multiply by 12 here and then multiply by 4 and multiply by 3, you're still going to find the lowest common denominator would be 24. Okay, so after finding 24 as the lowest common denominator, now it's time to order them, and they say descending, so we start from the largest to the smallest. So the largest here would be 15 over 24, which is the same as 5/8. Then it would be 1/2, which is the same as 12 over 24, and then it would be 1/6, which would be 4 over 24. So continuing now, still on page 48, we're still at exercise 3, and we're looking at number 2. It says that we should order the following: 7/16, 3/8, and 3/4 in descending order. So the LCM here would be 16, and this is how we arrive at it. We said 2 into 16, 8, 2 into 8, 4, 2 into 4, 2. 2 into 8, 4, 2 into 4, 2, 2 into 2, 1. We continued by saying 2 into 4, 2, 2 into 1, 2 into 2, 1, and we left the 1. And 2 into 2 one time, and we carried on the 1, and then we multiply everything outside. So this would be 1, 2, 3, 4. This would have been, or this is rather, 2 to the 4th, which is 16, because we say 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So our LCM or LCD, lowest common denominator, is 16. So 16 into 16 would go 1 time. 1 times 7 would give you 7. So 7/16, the equivalent fraction for 7/16 would be 7/16. because in this case we'll be multiplying both the numerator and the denominator by 1. We have 8 into 16 goes 2 times, so we said 2 times 3 would make 6, and our fraction would be 6/16 because we would multiply the numerator by 2 and the denominator by 2, and 8 2's would have given us 16 and 3 2's give us 6. Then 4 into 16, 4 is 16, so we multiply by 4, and 4 3's would give us 12. Time to order them. So we want descending order, so the largest one should come first. So 3/4 comes first because it has 12/16. Then 7/16 would come next because it would be 7/16. And finally 3/8 would come after because its equivalent fraction is 6/16. So I hope you're getting here that the first step is to make sure they have a common denominator. Then when they are common, we have 7/16, 6/16, and 12/16. Then we use our numerators to order them. Okay, let's do one more from this batch. So number 3 asks us to order 2/3, 3/4, and 7/12. Okay, LCD, lowest common denominator in this case, let me get a straighter line, in this case would be 12. It would be 12. Let's prove this again. 3, 4, and 12, starting with 2. 2 cannot go into 3 without leaving a remainder, so right back 3, 2 can go into 4 2 times, and 2 can go into 12 6 times. I'll continue with 2. Same scenario with the 3, 2 into 2 1 time, 2 into 6 goes 3 times. Now I move to 3. 3 can go into 3 1 time. 3 couldn't go into 1 without creating a fraction or leaving a remainder, and 3 into 3 1. Hold my line around here to show that I'm finding the LCM. So 2 times 2 would be 2 squared times 3. So 2 squared would be 2 times 2, which is 4 times 3. 4 3's or 3 4's would be equal to 12. So our LCD, lowest common denominator, or the same thing as the lowest common multiple, would be equal to 12. So that's how I ended up with 12 there. Now that I have found a common denominator, I'm going to create the equivalent fractions. 3 into 12 will go 4 times, so I'm using the factor of 4 to multiply the numerator and the denominator. So 4 2's would make 8, and 4 times 3 would have given me the denominator of 12. So the 2/3 is equivalent to 8/12. 4 into 12 will go 3 times. 3 times 3 would make 9, and 3 times 4 would have given me the denominator of 12. So my first fraction 2/3 is equivalent to 8/12, and the second fraction, which is 3/4, is equivalent to 9/12. Then 12 into 12 will go 1 time, and we multiply the numerator by 1, which will give us 7, and we were also going to multiply the denominator by 1, which would give us back 12. Now we're going to order them from greatest to least. So in descending order, 3/4 would come first because it is 9/12, and then 2/3 would come next because that would have been 8/12, and then 7/12 would come last. Okay, so that's it regarding descending order, and I won't go into the other set because ascending order just means that we're going to put them from smallest to largest. Now we continue on page 48, and we're looking at some concepts, some fractional concepts. We have proper fraction, right? So we have a proper fraction. We have the improper fraction. Good. And we have mixed number. All right, let's see. A proper fraction is less than 1. Its numerator is less than the denominator, and they gave us some examples here. They gave us 3/4, which is 2/4. We have 2/3, 2/3, and we have 7/8. So fraction, in this case, the proper fraction is less than 1, meaning it is not yet 1. When we were looking earlier at some of the concepts, how many more would we need on 3/4 to make 1 whole? We would need at least another quarter. We need another quarter. So 3 and the 1/4 would make 4/4, and in the case of 2/3, we would need another third, and in the case of 7/8, we need another eighth, 1/8. So all of these are less than 1. That's the point I want you to remember. So proper fractions are less than 1. Improper fraction, now let's move on. An improper fraction is greater than 1. Its numerator is greater than or equal to the denominator. So they gave us some examples here. They gave us 9/8, and they gave us 11/4, and 16/16. We know that 16/16 is equal to 1, right? Because this is simply saying how many times could I take 16 out of 16? 1 whole time. In this case, the numerator, as we can see here, 11 is greater than 4, and 9 is greater than 8. And moving into the mixed numbers now, we will see exactly how this fraction is considered to be greater than 1. But using what we had said before, 8/8 is 1 whole, plus another 8 would give us 9/8. See? So 9/8 is actually 1 whole and 1/8. So it is 1 and 1/8. Okay, and this is how we will end up with the mixed number. Alright, let's find out what a mixed number is. So a mixed number consists of a whole number and a fraction. It is greater than 1. So this is what we were saying right here. So we have whole number 1 and we have fraction 1/8. Okay, so they have given us examples here, as in 4 and 2/3, 6 1/2, and 5 3/4. Now, quickly, we see that there is a link between improper fractions and mixed numbers, because here we had 9/8, and we could show that 8/8 plus another 8 gave us the 8 and 1, 9/8, which shows we have 1 whole and 1/8, right? Similarly, we could change these mixed numbers back to improper fractions. And if we move to page 49 now and look at the top of page 49, it says, to change an improper fraction to a whole number or a mixed number, we divide the numerator by the denominator and write the remainder as a fraction in its simplest form. So we have an example here. They have 15/4, and we divide the numerator, which is 15 by 4. 4 into 15 would go 3 whole times, remainder 3 over 4. So if we say reverse that and we say 4 times 3 would give us 12, 12 and 3 15, here we have the 15 over 4. Let's use the example that we had established here. We have 9 over 8. Okay, so let me not put this equal sign here lest we get confused. 9 over 8, 8 into 9 would go 1 whole time, would have a remainder of 1 over 8. Okay, they gave us another example. They said we have 24 over 8, and 8 into 24 would go 3 whole times, because 8 could go into itself one time, 8 into 8 one time, and 8 into 24 goes 3 times, or numerator being 3 or denominator being 1, and 3 over 1 is equal to 3 because 1 could go into 3 whole times. So our answer would be 3. Let us now move on to exercise 1 on page 49. It says we have some mixed numbers here. We have 45 over 2, and we want to see how we could change it from this improper fraction to a whole number or mixed number. 2 could go into 45 how many times? 2 could go into 4 2 times, and 2 could go into 5 2 times with remainder 1. So it could go in there 22 whole times, remainder 1 over 2. Okay. Number 2 has 77 over 5. And how many times could 5 go into 77? 5 could go into 7 one time, leaving 2. 5 could go into 27 5 times, leaving 2 remainder. So 15 and 2 over 5. Number 3. So this was number 1, number 2, and number 3. We have 12 into 38. 12 into 38. No, that's not correct. That would be number 4. We have 126 over 6. How many times could this work? We could say 6 into itself one time, 6 into the 12 would go 2 times, and 6 into 6 one time. This would be 21 over 1, which would be the same as 21. So that is the first 3 examples in exercise 1 on page 149. So again, we see how many times the numerator, how many times the denominator can go into the numerator. If we have any remainder, we write it as a fraction over whatever the denominator is, and we did 3 of those. Let us move on now to exercise 2, which asks us to change the mixed number to an improper fraction. And it says here, to change a mixed number to an improper fraction, we multiply the whole number by the denominator and add the numerator and place the result over the denominator. So they gave us an example. Let's go quickly to another page. They have 2 and 5/8, and we would say 8 times 2 would give us 16. 16 and 5 would have given us 21 over 8. Okay, so let's look at number 1, 2, and 3 from exercise 2. They have 6 and 1/3, and we need to change this to a mixed number, to an improper fraction, from a mixed number to an improper fraction. So we would say 6 times 3 would give us 18. 18 and 1 would give us 19 over the denominator 3. So this is number 1. Number 2, they had 15 and a half. We would say 2 times 15 would give us 30. 30 and 1 would give us 31 over 2. last but not least, we have number 3. So number 3, or mixed number, is 2 and 7/8, and this would be 8 times 2, 16, 16 and 7, giving us 23/8. So that's it. We're changing improper fractions to, changing mixed number to improper fractions, multiply the whole number by the denominator and add the numerator. That's it. To do it the other way around, while changing the improper fraction to a mixed number, we divide the numerator by the denominator and we write it as a fraction if necessary, or we write it as a whole number as the case may be. Now we turn to page 50, right? So we're at page 50, and we're looking at adding and subtracting fractions with like denominators. It says, when fractions have like denominators, add or subtract the numerators, write the sum of the difference over the common denominator, and simplify if possible. So like denominator in the example that they have here is 16. So whatever our answer is going to be, it is going to be over 16. So we have 3 plus 1 would be 4/16. Now we could reduce 4/16 even further by dividing the numerator by 4, which would give us 1, because 4 into 4 would give us 1. Hold on, let's fix this properly. So this would have been 4/16, and 4 into 4 would give us 1, and 4 into 16 would give us 4. So that is how they got a quarter. Similarly, on the subtraction side of it, we would keep our common denominator 12, and we say 5 from 7 would give us what, 2, and we would say 2 can go into 2 one time, and 2 can go into 12 6 times, our answer being 1/6. Okay, let's look at number 1, number 2 and number 3 from exercise 1 on page 50. They have 1/8 plus 3/8. 3 and 1 would be 4/8, and we could say 4 into 4 one time, and 4 into 8 goes 2 times, or answer being a half. Number 2, 8 and 4 being 12 over common denominator 13, or answer 12/13. Or last one here is number 3, 3/5 plus 1/5. 3 and 1 would give us 4/5, or answer being 4/5. Not centered, let's center it. 4/5. Okay, let's quickly move now to some items for subtraction. So we have 9. 9 from 13 would leave us with 4/16. 4/16 would leave us with a quarter, because 4 into 4 one time, and 4 into 16 4 times. We have 7/10 minus 2/10. 2 from 7 would leave us with 5/10. 5 into 5 one time, and 5 into 10 goes 2 times, which would leave us with a half. And we have 8/17 minus 2/17. 2 from 8 would leave 6/17. So that is all we need to know about subtraction of fractions with like denominators. Once the denominators are the same, we focus on the numerators and we just go across, add or subtract as the case may be. We're at page 50, and we are now looking at adding and subtracting fractions with unlike denominators. So the denominators are not the same. Let's look at the example that they give us in exercise 2, and the example is a third plus a half plus 1/8. Let's look at the steps they say we should use to solve. A. Find the LCM, or the least common denominator, LCD. B. Rename each fraction as an equivalent fraction. That means that you're going to make the fractions have a common denominator. Then you're going to add or subtract, and finally simplify as best as possible. Alright, so let's look. LCM of 3, 2, and 8. Using prime factorization, we have 3, 2, and 8. Starting with 2. 2 cannot go into 3 without leaving a remainder. Right back 3, 2 into 2 one time, and 2 into 8 will go 4 times. Let's continue with 2. So 2 into 3, and why we're continuing with 2 is because we have 4 here, and we could go into 4. 3 into 3, no, write it back. 3 into 1, no, write it back. 3 into 4 goes 2 times. Sorry, 2. 2 into 4 will go 2 times. Let's go with 2 again. And 2 into 3, write it back. 2 into 1, write it back. 2 into 2 will go 1 time. Now we move to 3. And 3 into 3, 1. And we write that 1, the others back. And multiply everything outside. So we have 2 times 2 times 2, which is 2 cubed, or 2 to the third, multiplied by 3. What's 2 to the third? 2 times 2, 4, 4 times 2, 8. So it's 8 multiplied by 3, 8 3. So our LCM, or LCD, is equal to 8 3s 24. So put 24 here. And now we say 3 into 24 would go 8 times. 8 times 1 would give us 8. Plus 2 into 24 goes 12 times. 12 times 1 is 12. Plus 8 into 24 is 3 times. 3 times 1 is 3. Okay. And we add 12 and 8 would make 20. 20 and 3, we have 23 over 24. And that's the answer that they have listed there. Okay, so watch the steps again. First, we found a common denominator. Then we made all of them equivalent. So we use the LCM, the prime factorization approach, to find the common denominator of 24. We made all of them equivalent. So a third was now 8 over 24, a half was now 12 over 24, and 1/8 was now 3 over 24. Then we went to step C, which was add or subtract. In this case we're adding, and we got 23 over 24. So that's that. They gave us another example with 11 over 12 minus a quarter. And in this case the LCM would be 12. 12 into 12 would go 1 time. 1 times 11, 11. Minus 4 into 12 would go 3 times. 3 times 1, 3. 11 minus 3 would give us 8 over 12. We can reduce. 4 can go into 8 2 times, and 4 can go into 12 3 times, our answer being 2/3. Let us now look at examples from items 1, 2, and 3. We have 3/4 plus 1, 12. LCM 12. 4 into 12 would go 3 times. 3 times 3 would make 9, plus 12 into 12 1 time. 1 times 1, 1. So this would now be 10 over 12. And we could use 2 into 10 would go 5 times, and 2 into 12 would go 6 times. 6 times, our answer being 5/6. Number 2. So for number 2, we have 4 7s plus 5 16s. To find the LCD for that, we could say, using the prime factorization approach, we say 2 into 7. We can't, because it will leave a remainder. We say 2 into 16, 8. Using 2 again, 2 into 7, going to leave a remainder, write it back. 2 into 8 will go 4 times. Using 2 again, 2 into 7, we'll leave a remainder, write it back. 2 into 4 will go 2 times. Using 2 again, 2 into 7, write back the 7, and 2 into 2 will go 1 time. Our next number that could go into this would be 7. Then we draw our L on the outside and multiply everything outside. So we would have 2 times 2 times 2 times 2. That would be 2 to the 4th. 2 to the 4th is 16, because 2 times 2 is 4, 4 2 is 8, and 8 2 is 16, multiplied by 7. 16 by 7 will give us 112. 6 7 is 42, carry 4, 7 1 7, and 4 11. Now we have our LCD of 112. So we now say 7 into 112 will go 16 times. So we say 16 times 4, and we have it here. It will go all of 64 times, plus 16 into 112 will go 7 times, and we say 7 times 5 will give us 35. So 64 and 35, 4 and 5 9, 99. So we have 99 over 112. Okay. Number 3. We have 7 9s plus 1/3 plus 3/4. 9, 3, and 4. Using 2. 2 can't go into 9 without remainder. 2 can't go into 3 without remainder. 2 can go into 4 2 times. Using 2 again. 1. Now we use 3. We had said 2 into 9, we'll leave a remainder, write it back. And 2 into 3, we'll leave a remainder, but 2 into 2, 1 time. Now we're finished with the 2, move to 3. 3 into 9 will go 3 times, and 3 into 3, 1. Using 3 again, we say 3 into 1, 1, and 3 into 1, 3 into 3 1 time, and we have the other ones there already, and we always try to go down to 1. Now we'll say 2 square multiplied by 3 square. 2 times 2 would be 4, and 3 times 3 would be 9. So 4 9s would be equal to 36. So our LCD, or the LCM, whichever you prefer, is 36. 9 into 36 4 times, so 4 times 7 would be 28, plus 3 into 36 would go 12 times. 12 times 1 would be 12, plus 4 into 36 would be 9, 9 3s 27. So 28 plus 12 plus 27, 8 and 2 will be 10, and 7 17, carry 1, and we have 1 and 2 make 3, and 1 4, and 2 6. So we have 67 over 36, but it does not end there. 37 could go into 30, 36 could go into 67 one whole time with 31 remainder over 36. And that's it for the basic addition of fractions with unlike denominators. Won't spend much time going through the subtraction. It's just the same thing using the same steps. Okay, so just remember, first step, you need to find the LCM. You need to rename each fraction as an equivalent fraction. You need to add or subtract the numerators and simplify if possible. We're on page 51 and we're going to look at how we add and subtract mixed numbers. Okay, there are different approaches, but basically we need to work out our fraction, if they're not the same, if they are unlike, then we need to find the common denominator for them, work that out, and add or subtract our whole numbers as the case may be. In this case, the LCM would be 6, 3 and 2. So 3 into 6 would go 2 times, so 2 ones would be 2, plus 3 into 2 into 6 would go 3 times, 3 ones would be 3. So we would have 7 and 2 6 plus 3 and 3 6, and now we'll say 7 and 3 would be 10, and 2 and 3 would be 5 over 6. Okay, you may have been told to deal with the whole numbers first, so 7 and 3 could be 10, and 10 plus whatever we get for the fractional part of it, 1/3 plus a half, and this would have been 6, and 3 into 6 would go 2 times, plus 2 into this would go 3 times 1, 3, so it would be 10 plus 5, 6, which would be 10 and 5, 6. Slightly different, but the principle is still the same. Moving on to number 1, we have 3 3/4 plus 4 5/8. We say 3 and 4 would be 7 plus 3/4 plus 5/8. LCM would be 8. 4 into 8 would go 2 times, so we would have 2 times 3, 6, plus 8 into 8 would go what? 1 time 5, 5. So we would have 6 and 5 being 11 over 8, plus whatever is outside there being 7. What is 11 over 8 as a mixed number? That would be 8 into 11 one whole time, and 3 over 8. So our answer would be 7 and 1, 8, and 3 8s. So page 51, exercise 1, and we're looking at number 2 now, which would be 9 and 1/5 plus 6 3/4. So we could say 6 and 9 would make 15. So 15 plus 1/5 plus 3/4. LCM would be 20. 5 into 20 would go 4 times, so 4 times 1 would be 4, plus 5 into 4 into 20 would go 5 times. 5 times 3 would be 15. So 15 plus whatever that is, so it's 15 plus 15 and 4 would make 19 over 20. So our answer is 15 and 19 over 20. Okay. Still on page 51, now we look at subtraction. They gave us 8 4/5 minus 2 1/2. We say 8 from 2 would be 6. We would have 6, and we have 4/5 minus 1/2. LCM 10. 5 into 10 2 times. We have 2 4s being 8, minus 2 into 10 go 5 times. 5 1s 5. We have 6, and 5 from 8 would be 3/10. That's one example. We move on to B, where they have 10 minus 4 3/4. Now we need to do something to 10 so that it will be a fraction with a quarter as a denominator. We will take 1 out of the 10, so we have 9, and that one we turn it into a fraction, calling it 4/4, minus 4 3/4. Since the LCM is already the same, we say 4 from 9 will leave us with 5, and 3 from 4 will leave us with 1/4. They gave us another example, example C. We have 7 1/4 minus 1 3/4. So 1 from 7 would leave us with 6, and we have 1/4 minus 3/4. We have a problem here in that we can't take 3 from 1. We need to take 1 from the 6, leaving 5, and that one we change it to 4/4, and we add it to the quarter we have here, minus the 3/4. Okay, so this now becomes 5, and 4 and 1, this would be 5/5 minus 3/4, which is 5 2/4, which is the same as 5 1/2. Okay. Finally, we have 5 minus 7/15. We will change this 5 to 4 and 1, and we take the 1 and it becomes 15/15 minus 7/15. So 7 from 15 will leave us with 8/15, and we have whole number 4. So that basically is how we would subtract. Okay, please pay special attention to items like C here, where you need to take, where you end up with a numerator that is less than what you have on this side, and you need to take this large number from the small number. So we would have to take 1 from our whole number, change it to our fraction 4/4, add it to whatever we have here, and then we subtract the rest from it. Alright, so just watch out for those. We're looking at number 1 on page 51 from exercise 2. We have 6 and 11 twelfths minus 2 and 5 eighths. Using an LCM of 24, we could say 2 from the 6, dealing with the whole numbers. 2 from the 6 would leave us with 4 plus the fractional part now. 12 into 24 would go 2 times, so this would be 22. 2 11 is 22 minus 8 into 24 goes 3, and 3 5s would be 15. Okay, so 15 from 22 would leave us with 7, 4, and 7 over 24. Number 2, we have 15 minus 6 and 4 ninths. Change our 15 now to 14 and 9 over 9 minus 6 and 4 ninths. So we say 6 from 14 would leave us with 8, and because the denominators are the same, and we say 4 from 9, so we have similar denominators, so we don't need to worry about the denominators or finding an LCM as we did there. So 4 from 9 would be 5 over 9, so 8 and 5 ninths. Let's look at number 3. And number 3 says 14 and a half minus 8 and 4 fifteenths. Our LCM here would be 30. We would say 8 from 14 leaving us with 6. We say 2 into 30 goes 15 times 1. This is how we'd get the 15 here. And 15 into 30 would go 2 times, and 2 times the numerator 4 would give us 8. That's how we get 8 there. So we say 8 from 15 would give us 7 over 30 plus our whole number, which is 6. So our answer would be 6 and 7 30th. Now we're at page 53 and we're looking at multiplying fractions, and it says there are different methods of multiplying 2 or more fractions. For example, they have here 1/5 multiplied by 2/3, and you could just multiply the numerator by the numerator, as in 1 times 2, 2 over 5 3s 15. Then they have 15 over 16 multiplied by 4/5, and in this case they cross cancel. They say 4 into 4 will go 1 time, and 4 into 16 4 times. 15 into 1, sorry, 5 into 1 5, and 5 into 15 3 times. Multiplying across now, they say 3 times 1 would be 3, and 4 ones would give us 4. Last example they have is 14 over 15 multiplied by 5 ninths multiplied by 3 sevenths. So now they say 3 into 3 goes 1 time, and 3 into 9 goes 3 times. 5 into 5 1 time, and 5 into 15 goes 3 times. they say 7 into itself 1 time, 7 into 14 2 times. Multiplying across, we have 2 times 1 times 1, which is 2, over 3 times 3, which is 9. 9 times 1 is 9. Now, when we are looking at multiplying mixed numbers, we need to change all the mixed numbers to improper fractions before we multiply. So 5 times 1 would be 5, plus 4, this would be 9 over 5, multiplied by 3 times 2, 6, and 2, 8 over 3. Then we move on now to say 3 into itself 1 time, and 3 into 9 would go 3 times. Multiply across if we can't do any further simplification, and 8 3s would be 24 over 5 1s 5. We could put our answer back as a mixed number by saying 5 into 24 would go 4 whole times, because 5 4s would make 20, remainder 4 over 5. Okay. Another way, a whole number has to be given a denominator of 1. So again, changing our mixed number here to an improper fraction, 4 times 1 would be 4, and 3, 7 over 4 would be multiplied by 8, given a denominator of 1. So we say 4 into 4 1 time, and 4 into 8 2 times. Multiplying across, 7 2s would make 14 over 1 times 1, which is 1, and 14 over 1 is equal to 14. Of simply means to multiply. So this is 1/6 multiplied by 5/14. So let's change from a mixed number to an improper fraction. 6 times 1 6, and 1 7 over 6 multiplied by 5/14. That's not 14. 14ths. 7 into 7 1 time, 7 into 14 2 times. Multiplying across, we have 5 1s 5, and 6 2s being 12. Answer being 5/12. Now we move to page 53, and we are looking at exercise 1. We have 5 9s times 7. We need to give this a denominator of 1, and we would have nothing to cross cancel. So 5 7s would be 35 over 9. 9 could go into 35. 9 as close as 3, 9 3 is 27. Okay, so 3 whole times. And between 27 and 35, we have 8 over 9. Okay, let's look at number 2. We have 3/16 times 4. Give the 4 a denominator of 1. 4 could go into 4 1 time, and 4 could go into 16 4 times. Multiply across, 3 1s 3 over 4. Answer being 3/4. And finally, giving 10 a denominator of 1. 5 into 5 1 time, 5 into 10 2 times. 2 times 4 is 8 over 1. Our answer is 8. Students always ask, so sir, why you say 4 into 4 1 time and 4 into 16? When we are reducing, we try to find the highest common factor of these two numbers. So let's say use 2. 2 into 4 would go 2 times. 2 into 8 would go 8 times. 2 again. 2 into 2 one time, and 2 into 8 4 times. Now we can't go any further, so we multiply what's on the outside. So 2 squared is equal to 4, because 2 times 2 is 4. Remember, this is different from finding the LCM. LCM we will continue, but when we're finding the highest common factor of both, we only use the numbers that can go into both sets of numbers until it can't go anymore into both sets. Okay, for LCM we would continue using the 2, because 2 could go into 4, but it can't go into 1. But now we can't find any other number, saving 1, that could go into both 1 and 4, and 1 times any one of these is going to give you back the same thing. Okay, so 4, that's why we would say 4 into 4 is 1, and 4 into 16 is 4 times. So we are using the highest common factor of both 4 and 16. We are at page 54 now, and we're looking at exercise 2 number 1. So we have 1 and 1 6 multiplied by 5/14. Change our mixed number to improper fraction. 6 1 6 and 1. We have 7/6 multiplied by 5/14. Reduce where possible. 7 into 7 1 time, 7 into 14 2 times. We have 5/12. We're at page 55 now, and we're looking at dividing fractions. Key to dividing fractions is understanding the concept of reciprocal. So the reciprocal of any number is that number inverted. It can also be called the multiplicative inverse. For example, we have 2/5, and the reciprocal of that number 2/5 would be 5/2. So some people say it's flipped or it's inverted, right? But the rule is the reciprocal, a number, any fraction multiplied by its reciprocal will give a product of 1. So here we have 5 into 5 1 time, 5 into 5 1, 2 into 2 1, 2 into 2 1. 1 times 1 is 1, over 1 times 1 is 1. Answer 1. So the reciprocal, using that rule that the product 1, the product will result in 1, it means for 2/5 the reciprocal is equal to 5/2. Okay, then we moved on to exercise 1, which asks us to find the reciprocal of 17/19, and this would simply be 19/17. For number 2, it would have been 11/16, and the reciprocal would have been 16/11. For number 3, they asked us to find the reciprocal of 2 and 5/9, and this would have been 9 2s 18, 18 and 5 would have been 23/9, and the reciprocal of 23/9 would be 9/23. So that's finding the reciprocal. Okay, now we move on to the division component. They give us an example of 2/3 divided by 6. First, we would have to say 2/3 multiplied by the reciprocal of the divisor. So what's the reciprocal of the divisor here? It would be 1/6. Reduce where possible. 2 into 2 1 time, 2 into 6 would be 3. 1 times 1 would be 1, and 3 times 3 would be 9. Our answer would be 1/9. They gave another example. They said They said 5/12 divided by 5/9. We would say the dividend, which would be 5/12 multiplied by the reciprocal 9/5 of the divisor. The reciprocal of the divisor. So 5 into 5 would go one time, 5 into 5 one time, and 3 into 9 would go 3 times, and 3 into 12 would go 4 times. Multiply across. 1 times 3, 3 over 4 times 1, 4. Answer 3/4. Let's look at exercise 2, which says 9 divided by 3/5. So we have 9 divided by 3/5. We say 9 over 1 multiplied by 5 over 3. 3 into 3 one time and 3 into 9 3 times. We end up with now 3 times 5, which is 15 over 1 times 1. How many times can 1 go into 15? 15 whole times. Our answer is 15. We have 5/10 multiplied now by what? 1 over 10. 5 into itself one time and 5 into 10 two times. 1 times 1 and 10 times 2, 20. Answer 1/20. Now, when dividing mixed numbers, we write each mixed number as an improper fraction and find the reciprocal of the divisor, and then rewrite as a multiplication problem. So first, let's change this mixed number to an improper fraction. So we'll say 3 times 2 would be 6 and 1. This would now be 7 over 3 multiplied by the reciprocal, which would be 1 over 7. In this case, we'll say 7 into 7 one time, 7 into 7 one time, and 1 times 1, 1 over 3 times 1, 3. So 2/3 divided by 7, our answer would be 1/3. Okay, we're at page 56. We're looking at exercise 3, looking at number 1. We have 2 7/10 divided by 9. Let's change this mixed number to an improper fraction. We say 10 times 2 would be 20 and 7. 27 over 10 divided by 9 over 1. Now we're going to find the reciprocal of the 9 over 1. So it would be 27 over 10 multiplied by 1 over 9. Let's go now. 9 into itself one time and 9 into 27 goes 3 times. We say 3 times 1 would be 3 over 10 times 1, 10. Our answer would be 3/10. Page 56, exercise 3, number 11. We have 12.5 divided by 1 and 7/8. So let's go. Step 1, let's change our mixed numbers to improper fractions. We have 2 times 12, 24, and 1 would have 25 over 2 divided by 8 ones 8, and 7 would be 15 over 8. Then we are going to multiply the dividend by the reciprocal, the reciprocal of the divisor. So this needs to be inverted. So we have 25 over 2 multiplied now by what? 8 over 15. 2 into 2 one time and 2 into 8 would go 4 times. We say 5 into 15 can go 3 times, and 5 into 25 can go 5 times. 5 fours would make 20 over 3. We say 3 into 20 goes 6 times, because 6 threes would be 18 and 2 over 3. So 12 and a half divided by 1 and 7/8 would be equal to 6 and 2/3. The last part now of this topic, fractions, we have the fractional parts of quantities. Note, the quantity that comes after of must be the denominator. Always use the same units for both quantities. Example, what fraction of $1 is 50 cents? There are 100 cents in the dollar. Therefore, 50 cents is 50 over 100 of $1. Right? So, 50 over 100. And this would be 15 to 50 one time and 15 to 102. So it would be a half. So what fraction of $1 is 50 cents? So it would be a half. Alright. Let's look at exercise 1 and look at what fraction of $1 is 25 cents. So they say $1, but they quote in cents now. So we have to know that 100 cents make the dollar, and the numerator here would be 25 cents. 25 cents of the 100. 25 into 25 one time and 25 into 104. So 25 cents would be a quarter. What fraction? Number 2. Exercise 1, number 1, number 2. Number 2 is what fraction of $1 is 40 cents. So it's 40 over 100, and 20 into 40 goes 2 times, and 20 into 100 goes 5 times. So it would be 2/5. Let's look at one more. 3. What fraction of $1 is 5 cents? So this would be 5 over 100. Remember, 100 cents make the dollar, and we want to know what 5 cents is as a fraction. 5 into 5 one time, and 5 into 100 goes 20 times. So it would be 1/20th. Okay. We are looking now at page 57, exercise 1, and in particular number 10 to 13. We have changed units now. We're looking at what fraction of an hour is 45 minutes. So remember, they said earlier that the quantity that comes after of must be the denominator. So of an hour, the hour will be the denominator. They say number 10, 45 minutes. So we need to change that hour into minutes. How many minutes make an hour? 60 minutes make an hour. So 45, what is 45 minutes of 60 in fractions? So 15 into 45 would go 3, and 15 into 60 would go 4 times. So it would be 3/4 of an hour. 30 minutes of an hour as a fraction. 30 into itself one time, and 30 into 60 goes 2 times, so it would be a half. What about 1 over 60? 1 into 1 one time, and 1 into 60 60 times, so it's 1/60th. And 10 into 10 one time, and 10 into 60 6 times, so this would be 1/6. We're at page 57 looking at exercise 2, and it says solve the following problems. Number 1, express $1.50 as a fraction of $6. And if we have 100 cents in a dollar, and we have $1.50, it means we have 100 cents plus 50 cents, which would give us 150, as expressed in our numerator here. And $6 is really 6 groups of 100 cents. So 6 times 100 would give us the 600. So we could, using some of our knowledge of division, 0 cancel 0, and we could say 15 into itself 1 time and 15 into 60 4 times. So $1.50 as a fractional of $6 is a quarter. Number 2. So page 57, exercise 2, number 2. What fraction of 2 years is 10 months? So we know that the 2 years will go at the bottom as the denominator, and they're talking about months. We have to make them the same. So 2 years is 24 months and 10. 2 could go into 10 5 times, and 2 could go into 24 12 times. My answer would be 5 twelfths. So this is it basically for our review of our unit on fractions, and we have covered a lot. We have gone all the way from what a fraction is. We know about the numerator, the denominator, the fraction bar. We looked at identifying the shaded versus the unshaded portions, finding equivalent fractions. We know that they have the same value but different names. We went into comparing fractions and reducing fractions. We looked at fractional concepts to include a proper fraction, an improper fraction, a mixed number. We did the adding of fractions and subtracting of fractions with like denominators and unlike denominators, and we did some multiplying of fractions and dividing of fractions. Please take time to review examples from this unit over and over and prepare for your unit review test, which will be coming up soon. Thank you very much.